Prompts, they look so simple, right? A few lines of text. But here's the thing. Those simple lines are sitting on top of these incredibly complex AI systems. And when they fail, oh, they can fail in some truly spectacular ways. So today we're going to dive into a framework to make absolutely sure your prompts are ready for the real world.
So let me just start with a question for you. What if one single line of text, one prompt, could vaporize $100 billion from your company's value? It sounds totally nuts, like something out of a sci-fi movie, but it's not.
Because, well, it's already happened. We've seen a chatbot offer a brand new $76,000 SUV for a single dollar. We've seen sensitive company source code just leaked out into the open. And yeah, that $100 billion thing, that was a simple astronomy mistake in a demo. These weren't some deep, complex code bugs, nope. They were prompts that probably looked totally fine, but just completely shattered under real-world pressure.
And this gets us to what I'd call the industry's dirty little secret. I mean, despite these massive, massive risks, most teams are still just relying on a few manual spot checks. They're basically just pushing their prompts out the door and, I don't know, waiting for the angry customer tickets, or worse, the news headlines, to tell them that something is horribly wrong. Okay, so let's really dig in and quantify what that failure actually costs, because it is so much more than just a bad headline.
Now check this out, because this chart just reveals how fragile this stuff really is. A recent clinical study found that if you just slip one fake detail into some physician's notes, the AI models would hallucinate, just make stuff up, 82% of the time. And even with a specially designed mitigation prompt, the error rate was still a shocking 44%. This is not a stable system we're talking about. It's a minefield.
But here's the good news, and it's really good news. We can actually do something about this. Field studies are showing that a really disciplined stress testing process can slash these production incidents by up to 80%. I mean, that is a huge game-changing improvement in reliability.
And this slide just perfectly illustrates that the costs of failure really come in three different flavors. You've got the reputational hit, like Alphabet losing $100 billion in market cap. Then you've got the direct financial costs, like a sudden 30-time spike in your token costs. And then you've got the big regulatory fines, like a 15 million euro GDPR penalty. Every single one of these is a business-critical risk.
So how do we stop this from happening? We do it by adopting a 5-step stress test. The core idea here is really simple. We have got to start treating our prompts with the exact same seriousness that we treat our production code.
This right here is the central philosophy. A prompt isn't just some friendly suggestion you give to a model. It's an instruction. It behaves like code. And you know what? It deserves the same rigorous discipline we apply to everything else we ship. Unit tests, load tests, security scans. Well, prompts need their own version of that too.
All right, so here's the framework itself. It's a 5-step process. First, you define what success and failure actually look like. Second, you build a data set of challenges. Third, you automate the whole testing harness. Fourth, you run a whole battery of stress scenarios. And finally, you analyze the results to decide whether to ship or not. It's that simple.
So, step 1 is all about moving from these fuzzy goals like, don't hallucinate, to objective, machine-verifiable guardrails. You define crystal-clear metrics for things like accuracy, latency, and cost, but also for the qualitative stuff like brand tone. And, most importantly, you decide way ahead of time what counts as a hard failure, something that just blocks a release, no questions asked.
Next up, you build your challenge dataset. And let me tell you, this is absolutely crucial. It can't just be the happy path examples. No, you have got to mix in the nasty stuff. Real, anonymized production traffic combined with adversarial inputs like misspellings, contradictory questions, and queries that are specifically designed to bait your model into violating a policy.
Now, I know what you might be thinking. This sounds like it's going to slow us way down. But the goal here is a repeatable process that adds hours, not weeks, to your existing pipeline. A typical run of hundreds of these queries across different models and settings, you can get it done in under 4 hours for just a few bucks in API calls. This is totally doable.
And that speed, well, that's what lets you move from a one-time fix to a truly sustainable framework. This is all about making quality a habit, not just a one-off project.
So, what's the standard we're even aiming for? Let's call it the S-tier prompt. This is the gold standard. It's defined by excellence across 5 key criteria: specificity, structure, value, consistency, and originality. It's the benchmark for what a great, production-ready prompt actually looks like.
And this slide right here just connects all the dots perfectly. The S-tier standard is the goal. That's what a high-quality prompt looks like in theory. The stress testing, that's the proof. That's the repeatable process that verifies your prompt actually meets that high standard when it's put under real-world pressure. One is the dream, the other is the reality check.
So, to make this a habit, here is an actionable checklist for you. First off, treat your prompts and data sets just like any other critical piece of code. Version everything in Git and keep your golden answers for correct outputs under source control too. And when you test, don't just use your production temperature setting, push it to the extremes to see where it breaks. And this is critical. Your CI job has to be configured to fail the build instantly if any policy-violating content is generated. No exceptions.
Next, simulate your real production load so you can catch latency problems before your users do. Log every single run and generate clear scorecards that show you exactly what got better or worse with each change. And remember, the models themselves can drift over time, so you have to schedule weekly regression tests to catch it. Finally, and this might be the most important part, close the feedback loop. Every single failure that happens in production must become a new automated test for tomorrow.
When you put all of this together, it stops being some optional extra. This just becomes the new professional standard for shipping AI products with real confidence.
Ultimately, the goal here is to move prompt engineering from being this mysterious art, a craft practiced by just a few, into an auditable, automated, and scalable engineering discipline that anyone can follow.
The long-term benefit here is just profound. When you adopt these practices, you stop relearning the same painful lessons with every single release. Instead, what you're doing is building a rising floor of reliability. Each new release is built on the quality and the learnings of the last one. You're literally building compounding quality.
And that leaves us with one final, very simple question to take away from all this. It's the question we should be asking ourselves before every single deployment. Is your prompt really ready for the real world?